Yes, today is the class on the carboxylic acid and its derivative, and it is set number 12 continuation of set number 2, set number 11, and in consecutive we are going to solve out a lot of questions answer of competitive exams and lot of questions for practice, and these are the practice set solution, and this very important topic today is carboxylic acid. Before starting the solutions of different entrance exam questions, let us first tell something about the preliminary things, because today's topic is on introduction. A lot of questions are asked, very often are being asked in different entrance exam. So what is carboxylic acid? You know the carboxylic group is COOH. So carboxylic acid is aliphatic carboxylic acid RCOOH in aromatic carboxylic acid equal to ARCOOH. Means one is CH3COOH, another is benzene COOH, benzoic acid and acetic acid. This is known to you. I am not writing. In short, I will go a bit fast. And next one is monocarboxylic acid of aliphatic series is called fatty acid. And trans exam very often asks which one of the following acid is the fatty acid. Mind that in fatty acid you will just get one carboxylic group. There should be one carboxylic acid. So monocarboxylic acid in aliphatic series is called fatty acid. Am I right? So it will be long change of the carbon having one COOH is called fatty acid. So you can very easily get the clue where there is one carboxylic acid is there is the fatty acid. And next point is that there are some higher fatty acids also. And in trans point of view, higher fatty acids are stearic acid, palmitic acid, and stearic acid or oleic acid. All are monocarboxylic acid. So what is palmitic acid? Very often comes in your exam. Palmitic acid. Palmitic acid is carbon 15 and hydrogen double plus 1. 15 plus 30, 31 COOH. And what is stearic acid? It is carbon 17 and hydrogen double CnH twice n plus 1. So it is 34 and 35 COOH. So these are the examples of higher fatty acid. Monocarboxylic acid, there is higher carbon number is more and more is higher fatty acids are example of palmitic acid and stearic acid. Palmitic acid is carbon 15 and stearic is carbon 17 and hydrogen double plus 1 is equal to 31 and other is equal to 35 and COOH 1 equal to carboxylic fatty acids is having one carboxylic acid should be there. So next one is dicarboxylic acid, very common, you know it in practical exam you have got is oxalic acid, but in oxalic acid some crystal of water is there. I am not assuming it is so COOH oxalic acid and lots of dicarboxylic acids are there. So though these things are not important for entrance point of view or class point of view, thereby I am not wasting time on this one. So unsaturated carboxylic acid, unsaturated carboxylic acid means there should be double bond. Am I right? And one is COOH and COOH, and if you H and H, and if you arrange in different way, this malic acid. So since there is unsaturation in there, it is the fumaric acid and stearic acid. Fumarase is actually in cis position, there is COOH, and in trans sorry, it is in trans position COOH, and it is cis in the same site is equal to cis position COOH. One is malic acid and other is fumaric acid. Some entrance exam this question sometimes asks, that's why I have told you unsaturated carboxylic acid is fumaric acid and malic acid. And next one is oil of wintergreen. In a lot of entrance exam we will solve out these questions, you will get it. Oil of wintergreen, it is in nature we get this substances, and it is called, it can also be synthesized, and this is called methyl salicylate, and the formula is, so this is methyl salicylate, and very often it is termed as oil of wintergreen. So just keep it in your mind. Tartaric acid, this is very important because This is called tartaric acid. You please try to keep it in your mind. If this is there is some optical chiral centers of the carbons instance, hence it is an optically active compound. Very often it is asked in the entrance exam which of the following is an optically active, and very often tartaric acid is given. This tartaric acid is like this. So if it is optically active, and if this is written in this way, it is asked sometimes in entrance exam neat 2 years back. The question was asked then whether this is optically active or not. So first of all, let me tell something about this one. This is chiral center because in its four hand, one hand is H, other hand is OH, other is COOH, is three different substituents are attached, and whole this gives you other. So four substituents are different, so it is chiral. Likewise this is OH, this is H, this is COOH, it is three different, and whole branch will give you another. So there are two chiral center, but its arrangement will tell you which of the structure is optically active. This structure is optically active and this structure is not optically active, because here there is optical center of the line, or the line through which this can be divided into exactly equal two parts. If you just superimpose to the other, the OH will fall upon other, CO, this H will be fall upon this one, and this type the compound, though it has having two carbon chiral center, yet due to this line presence of this line which divides the molecule into two equal halves, this molecule is called meso, and this mesotartaric acid not optically active, and this is optically active. That's why I have tartaric acid mentioned here. And next one is glycine. Glycine is very important because in glycine, this is glycine, and lot of information regarding glycines. Very often question is asked in glycine part 7. This is acid group and this is base. Am I right? So this act as acid, this acts as base. So this is acid and base. Am I right? So more than this, another important question is that this is very often occurs as like this. This molecule very often occurs is like this. So in the same molecule, if there is a positive negative charge occurs, one is acid groups and other base groups, so one hydrogen is come to this one. If this occurs, then this is called Juita ion. So sometimes in exam, which one of the following is Juita ion? So structure may not be given, it may be given glycine. So glycine will be your answer. Am I right? So that's why here I have in important compounds, I have mentioned glycine. And vinegar is also very important because it is nothing but another name of acetic acid, and here in sometimes in exam it is told what is the percentage of acetic acid to be act as a vinegar. In treacle making we can use vinegar. So this vinegar is nothing but acetic acid or ethanoic acid, so which is 8 to 10%, and this percent is very important asked in entrance exam. That's why I have written here vinegar. And urea formula of urea is NH2CO NH2, and this is important because no acetic base, there is base and it is termed as monoacetic base, hence urea is also used. Which one of the following is acidic base? And answer is urea. So this is all about the background. Now let us try to solve out the entrance exam solutions, and some of the questions are already been chosen by me. So you see, first one is tribasic acid. Which one of the following is tribasic acid? It is asked in MHCET. Tribasic acid, oxalic acid. A bit earlier I have told you there is COOH two groups, it is dibasic. COOH two group, dibasic. Tartaric acid, I have already shown you there are 4 carbon above and below, there is COOH. Again it is dibasic. Lactic acid and citric acid. Come out to the citric acid. So the citric acid is equal to, the formula is So this is citric acid. So in citric acid, we have seen C double OH, C double OH, C double OH. So the answer is citric acid. So next one, urea is, a bit earlier I told you urea is monoacidic base. So it is asked in CPMT, MP, PMT. Now the third question is, glycine may be classified as a base and acid as deuterion all. Asked in JIPMER. I have already told you the structure of glycine is, this is glycine, this is glycine. So this is acid, this is base, and we can draw glycine like this. So in the same molecule there is positive and negative ion, so it is deuterium. So in the option all is correct. So next one, trichloroacetic acid, fluoroacetic acid, acetic acid, formic acid, order of acidity, CBSC PMT preliminary exam. So trichloroacid, what is acetic acid? CH3 COOH. Now when it is trichloroacetic acid, means in place of H there is 3 chlorine. Fluoroacetic acid means 1 fluorine is there. Actually this is CH3. So in place of CH3 there is 1 fluorine. And next one is acetic acid, means CH3 COOH. And last one is formic acid, HCOOH. You are asked to write the order, and it is very important question, very often asked. Acidity of an acid increases with increase in number of minus I effect. Minus I effect facilitate the acidic behavior of organic acid. So fluorine, chlorine, bromine, all are minus I effect that withdraws electron. Am I right? So if COOH is there and here there is CH2 like this, and somewhere there is X, then X withdraws electron and thereby the bond between O and H is weakened. So inductive effect is shown in this way due to withdrawal of X halogen group. So the electron moves in this direction. So in this way OH bond weakens. So it facilitates the removal of H as proton. So acidity increases with minus I group. Now if the number I group is more, then more is the acidity, more weaker is the OH of COOH group, so more stronger the acid is. So this is the highest, number 1. So next one is fluorine. It is no doubt minus I effect is a stronger, but number is 1 here, number is 3. So it is in second position. It is second stronger. And now third stronger is this, and least is this. Here the order is a bit changed, because here what's happened in acetic acid, it is plus I group. Am I right? When there is plus I group, then that OH group electron pumps, the electron density increases. It is the reverse of the minus I group. If plus I group is attached, the OH bond of COOH becomes more denser. Hence, release of H as proton is a bit tough. Hence, it will be weaker acid. But here there is no such plus I group is there. So it is as usual acidic. It can very easily donate hydrogen as proton, but it cannot donate as easily due to plus I effect and more electron density between O and H. Release of H as proton is tougher. So this is the highest, this is second, this is third, and this is the least. This is the order. This is the very important, and later often you will get this one. Next one is sodium potassium salt of higher fatty acid. Higher fatty acid means soap. You have some stearic acid and palmitic acid, oleic acid. You have got carbon 15 and carbon 17 higher fatty acid, and if fatty acid is COOH in place of higher C15 and H31 COO, if you place a higher sodium or potassium, that becomes salt. Sorry, soap. So that gives you soap. Am I right? So sodium potassium salt of higher fatty acid will give you a lot of options are there. I have omitted these options. That question is soap. Next one is a bit critical, hence it is asked in IIT and JEE. COOH group is present in picric acid, barbituric acid, ascorbic acid, aspirin. So what is picric acid? So you should know it in other chapter, you have got it. So there is, though it is acid, but there is 3 nitro group in here and OH group is there, and it is 2,4-cis dinitrophenol. It is picric acid, though there is no COOH, still it is acidic. Barbituric acid, it is a cyclic compound. The structure is a bit complicated. I am not losing time to write the structures. That is cyclic, not benzene structure is there. And ascorbic acid, this is heterocyclic. The structure is 5-membered ring is there, and a bit plus double bonds are there, and it is also not aromatic compound. But when you will come to aspirin, and it is very important compound, aspirin is COOH or CO CH3, and it is very important medicine also for headache and this and that, and hence aspirin is very important. In aspirin you should keep the structure in your mind. You should know the structures of aspirin, and so the COOH group is present in aspirin. Until and unless you know the structure, you can't answer the question. And next one is which do not contain COOH. It is CDMT, Aligarh Muslim University Medical College, and GUJCET question is very often asked. Do not contain COOH. Aspirin, already I have shown you there is COOH group, and benzoic acid there is COO group, you know it. Picric acid there is OH groups and 3 nitro group. Salicylic acid there is COO group and OH group. Am I right? So out of this you can choose this. In picric acids, though it is acid, we have a very general conception that when there is an organic acid there is COOH is there, but in picric acid there is no COOH. So answer is do not contain. Answer, picric acid do not contain any COOH group. Next one is most acidic. ClCH2COOH, C6H5COOH. This answer CH2COOH. Here there is Cl, and here C6H5COOH. One is C, D, D and D, COOH, and other is CH3CH2COOH. You are asked, it is asked that which one is the most acidic one. The most acidic, already I have told you, the acidity of an acid is facilitated due to the presence of -I group. So the compound which have -I group attached will be the more facilitating group, because it's loosen or it release or it lessen the electron density in OH group, thereby release of hydrogen and proton will be very easier. So it will be the strongest one. So more strongest acid is chloroethanoic acid is the strongest one. So next question is distinguishing test for methanoic acid and ethanoic acid. It is very tough, you can't answer it, and it is in CASCET exam is asked what is methanoic acid. Methanoic acid is this and ethanoic acid is this, you know it. It is methanoic in ethanoic. How can you distinguish? A lot of options is given, but due to with the help of Ag2O means tolerance reagent may be written in this way. tolerance reagent, we can distinguish the options Ag2, or we can distinguish these two. So you will be confused at this point, because tolerance reagent very often act upon CHO group of aldehyde, and it is a mild oxidizing agent, ammonical silver nitrate solution or Ag2O, and it oxidizes this group of this, and thereby it itself get reduced to give you silver. So this is tolerance, the main reactions of tolerance reagents. It oxidizes, mild oxidizing, it oxidizes the CHO group to COOH groups, and it itself get reduced to become tolerance reagent. It is silver nitrate AgNO3 whole thing 3 OH negative. We can write in this way. From this complex, it comes out as Ag, hence it is reduced. It get reduced in presence of aldehyde group. But how can you just distinguish this with tolerance reagent? Answer: this reacts with tolerance reagent, but it does not react with tolerance reagent. Now, when the answer will be given in this way, you will be think of the fact that how there is CHO group, there is no CHO group, how can tolerance be get reduced, or it will be oxidized further? COOH, OOH cannot be oxidized further. Am I right? So the style of writing this one is, if you write HCOOH, we can write this as this one. So we are getting two part of CHO, and this part is also CHO, and this two part of CHO with tolerance reagent, if you write Ag2O or silver NH3 whole thing 2 and OH, this is also another representation of tolerance reagent. This tolerance reagent get reduced as silver from the structure, it moves, it becomes this. So now what's about this? This is not oxidized, this become carbon dioxide and water. So above all, we can say that formic acid, or yes, methanoic acid or formic acid get reduced with the help of tolerance reagent, because simultaneously if you draw the structure, we see that CHO and CHO is there, that's why it breaks up into carbon dioxide, water and silver nitrate. Where about? And this here we can draw this, can't draw this in this way. One will be CHO, another will not be, hence ethanoic acid will not respond to silver nitration. This is very important reaction. Please keep it in your mind. It is a bit tough. So next one is again tremendously important. You see which one of the following order is not correct. First order is given CCl3. You may not see properly in lower part. That's why I am once again written Cl2 CH, Cl CH2 COOH. First order is given. You have to check which one is not correct. It is first order. Answer: when the minus I group is more, then OH of COOH will be more less weaker and electron density is less, thereby it will facilitate the release of hydrogen as proton. It will be strongest one. So here 3 minus I group, here 2 minus I, here 1 minus I group. This is correct order. Next one is CH3 CH2 Here let us try to examine whether this order is correct or not. Here you see all this carboxylic acid has got number of minus I group, one group. But here one thing is carboxylic acid OH group is here. For one I am showing you here H is there. So we need to release this S1 H1. So it is facilitating. Am I right? It is facilitating in which way? Because this chlorine group, chlorine withdrawing group minus I group is very close to COOH. So force of attraction or withdrawing the electron is in a more stronger manner than other. So it is adjacent to this, the electron withdrawing capacity is more pronounced. Now here it is here, am I right? So here this chlorine is attached to, not adjacent, next to, so its minus I capacity is a bit less pronounced than this for the distance of the minus I group. And now it has come to 1 2 in third carbon. So here it is again less pronounced as it has moved to this one, because we see that the inductive effect is beyond carbon 3 is almost nil. So if you go far and far and far away, so inductive effect will be less. So it is so close, that's why it is the highest, it is second, it is third, hence this order is also correct. Now come to this one, the HCOOH is CH3COOH and C6H5COOH. Let me explain here. pK value 3.7, 4.1. Let us check this one. It is formic and here acetic acid and here this. No doubt formic acid is the strongest one, because here plus I effect is there. Plus I effect will increase the electron density between O and H of COOH groups. Am I right? It has some minus I doing effect, so there is a confusion which one will be the highest or not. So here you just come to the point that here pK value of this one is 37 and pKa value for this is 4.17 and pKa value for this is 4.7 value 76. We know that acidity is inversely proportional to pK value. Lesser the pK value, more is the acidic. So in this term it is the highest, it is okay. So out of this so from pK value we see that this is the least value and second least value is this. This should be before this one. So I told you earlier that phenyl group has a bit electron withdrawing group nature is there, but it is electron pumping group. So from that expansion point of view, this should be in second, this is first, this is second, this is third. On terms of pK value, this value is least, hence this is the order. So your question is, the wrong order is this is the wrong order. But what is the number of fourth order is, what is fourth is CH3 COOH CH3 CH2 COOH CH3 all thing 2 CH COOH. Whether this order is correct or not, answer it is correct, because CH3 group is plus I group. It do not facilitate, it retard the release of H as proton. Am I right? So here CH3 group COOH. So here electron density will increase, it will be rich in electron density, release will be a bit tough. So it is weaker till it is the highest acid in terms of other these two, because here it is methyl, here it is ethyl. So plus I effect of ethyl is more than methyl. Am I right? So it is more plus electron pumping group. So more pumping group is that it is less acidic. Here more CH3 group, 2 CH3 group is there. Again it is least acidic. So here more the plus I group, or more is the electron pumping nature, more is the length of the alkyl group, more is the plus I capacity, so less is the acidity, or more is the number of CH3 group, more is the less is the acidity. So arrangement of 4 is also correct. So your answer is C. The last asked to write the IUPAC name of isotonic acid. So for it will be difficult for you to know this structure. So this is thalic acid, means there is COOH groups. Isotonic means in 1,3 position there is COOH, isotonic acid. So you will write benzene 1,3-dicarboxylic acid. This is the IUPAC name of isotonic acid. So this is all about of today's class. So in the next class, I will go through the preparation of carboxylic acids and will solve out the reactions, solution of the entrance exam, solution of different questions answer. Thanks a lot for watching the class. Once again, I request you, to those who have not subscribed the class, requested to subscribe the class to remain updated.